Now we're going to learn how to find the VSWR voltage standing wave ratio of a particular load using the Smith chart easily. Why easily? Because it's easy to do. So here's how you do it. Steps. If you know how to plot the impedance, do it. So in this case we're talking about loads, so if you have an antenna and you want to find out what the VSWR of the antenna is, you plot the impedance, load impedance of the antenna, you draw something called a VSWR circle, and you look. Those are the steps. It doesn't get much easier than that. So I'm going to show you some examples and then you'll see how easy it is. 3 loads. Load A, impedance is 100 minus J 100. Load B equals, let's say 50 plus J 100. C, load impedance equals. Okay, so I'm going to be assuming that the characteristic impedance is 50 ohms. There. So on a 50 ohm line, here's one antenna, here's another antenna, here's another antenna. We'll plot all these 3, and then we will draw VSWR circles, and then we will look and find out what the VSWR is. Okay, so for the first load, I can say the normalized impedance, right, if we divide by characteristic impedance, is 2 minus J2. In this one, 50, so 1 plus J2. And this one, normalized impedance, 1 plus J0. Done. So I plot 2 minus J2, I draw a circle, and I look. So the first one is what we'll do first. 2 minus J2. So I'm going to call this one VSWR, and I do 2 minus J2. I look along the R line for 2. 2 is here. It's minus J2, so I only have to go trace down here. And then I look for minus J2, which is here, 2.0. I go like that. I plot the impedance, and I'm going to call that A. Okay, why am I calling it A? Because that's what I called it here, A. So that's that. Then I draw a circle. So, and I said the center point of the circle is always the center of the chart where it says 1.0. Always. Center goes there. Draw my circle. There's my circle. Hope you can see it. So I've drawn my circle, and then the third step is look. Look. Wherever this circle crosses this point, whatever that number is the VSWR. So that's 4. That's 4.2. Looks like 4.2 to me. So I can say VSWR equals 4.2 to 1. Done. That's A. Okay. So now here I say for this load, VSWR is 4.2 to 1. Okay. Next one is B. 50 plus J100, 1 plus J2. Okay. That could be 50, 1 plus J2, this is 1. Plus J2. That's B. I'll make a new circle. So every load that would have an impedance on this circle has the same VSWR. So now here, I look. What number is that? Well, this is 4, this is 5, this is 6, so it's a little bit less than 6. So VSWR is about 5.8 to 1. That's done. So I plotted the impedance, I drew the circle, and I looked, and there it is, 5.8 to 1. That's B. One more. C. 1 plus J0. So I go along here and I find 1. I can trace that circle. And 1 plus J0. So I look along here. Oh, 0 is this one. The straight semicircle. So this is C. This is actually a perfect match. Perfect impedance match. 1 plus J0 is right here in the center of the chart. So what do? I have to draw a circle where I put the center in the center of the chart. This is actually VSWR circle of perfect match has a radius of 0, right? So my circle is actually a point. I just go like that. So if I look at my circle, where the circle crosses here, VSWR is equal to 1, which is the VSWR of a perfect impedance match with no reflected power. And that's how you find VSWR on a Smith chart.